Hey everybody, Matt here for Imagine Then Make. Thanks for stopping by. Well, this is part 11 in my series of videos teaching complete beginners how to program in Python. If you missed any of the earlier episodes, just check the video description for some links. All right, so after you've written your Python script or your Python program, you're going to want to thoroughly test it to make sure that it functions the way you intended. And really, when you run when you're testing your program, you're really looking for three different kinds of errors. The first kind of error is like a syntax error, where there's a typo in your source code that your IDE perhaps didn't catch for whatever reason. Those are reasonably easy to catch, and they're very typical, especially for new and experienced programmers alike. We all make typos. The second kind of error is like a runtime error. That is an error that only occurs when you actually run your program. An example of that would be, say, trying to divide by 0. Okay, so that would produce a runtime error. And the third kind of error, which is a little bit more difficult to find or catch as you're writing your code, are what are considered logic errors, meaning all the code is syntactically correct. There's no typos. Everything's typed in correctly. It just doesn't function the way you intended it to function. So somewhere in your code, there's one or more logic errors. Okay, so we're going to talk about a couple of different ways to try and catch those kinds of errors. All right, so there's two different ways that I use to test Python programs. The first one you've already witnessed me doing if you've been following along with all the other earlier episodes, and that is clearly the easiest, at least in my opinion, it's clearly the easiest for beginning programmers to utilize, and that is to intersperse print statements or commands into your source code at strategic locations so you can determine where you are in the program as it's running and what the value of different variables are, or what have you, whatever it is you're trying to test. So let's see if I can find an example here. Okay, so inside of the data validation section of the program, right, test number 2 has this commented out print statement, print integer guessed. So test number 2 uses the isNumeric method as discussed previously, and if that returns true, then that means only numbers were entered, or an integer, no floating point numbers, okay? And no negative numbers and no letters, punctuation symbols, or anything like that, right? As we talked about before. So I thought while I was developing this that it'd be advantageous to put a little print statement in there that displays integer guessed when I got to this section of the code, and I knew the code knew that only an integer was entered, so I just wanted some validation of that on the screen, something printed. So, and then when I no longer needed that print statement, I just commented out. You can choose to delete them, but while I'm developing, I tend to just comment out these kinds of extra print statements just so I can go back and turn them back on again in the event that I need to or want to. Which reminds me, here's another shining example of that approach. When we generate a random number and have it saved into the r_num variable, I have a print statement here, print random number, and then the string value of the number. Okay, and then I print a blank line. These two print statements are really there for development purposes. Since the user is trying to guess what the random number is, you wouldn't want to display it on the screen. That kind of defeats the purpose of having them guess. So, but for development purposes, it's very informative to know what that number is, so that as you run through the rest of the program, you can determine if it's functioning correctly. Okay, so in a future version, just in a few minutes, I'll turn these off by simply adding a pound symbol in front of the print commands, turning them into comments rather than executable statements. Okay, so those are examples Here's another one. Thanks for your guess. This was commented out at one point or another. It was valuable to me to see that I was at this section of the code. Okay, so hopefully that explains how that works. I have used these extra print statements in when I'm writing code in all kinds of different languages. I've never really come across a system that I was writing code for that didn't have some way of displaying characters on a screen or a display of some kind. So I utilized that method. Okay. The second method is a little bit more rigorous, but it nullifies the need to put in these extra print statements. And that is to actually use the debugger that comes with the Python package. So let me, let's see. Let me go ahead and turn these into comments. So I'm just going to put a couple of pound signs right here. Okay, and I'm going to save it. Okay. Now, in order to turn the debugger on, the debugger that comes with Python, and remember we're using the IDLE IDE or development environment that comes with the Python package when you download it. Okay, so I am going to run this menu item right here, the Python shell. Previous to this, we've been running the module. This time I'm going to run the Python shell. That's going to basically open up the Python interpreter. You'll recognize the three little carrots right here. Once I have this window open, I can click on debug, the menu debug, and then click on debugger. And that puts a little check symbol next to that menu item. Let me show you. So the debugger is turned on, and it also opens up this other little debug control panel. Okay, so let me rearrange my windows a little bit so they can be a little bit easier to read. Okay, so in this debug control panel, it looks a little, the first time I saw it, it's like it doesn't look very user-friendly, and it's not terribly obvious about how to use it. Okay, but you saw me just start it, and you can see all four of these checkboxes are indeed checked. So I'm going to leave all four of these checked. Okay, and then I'm going to actually run the program from over here. Okay, so I just clicked on run and run module, which is what we've been doing through the whole series of videos. Okay, and when that happened, I just lost it. Okay, so I just restarted it. So what happens is it highlights the first line in the source code that it's actually going to try and execute. Okay, and you can see in the idle shell that I've restarted the Python interpreter, and it shows me what program I'm running. And then over here in the debug control panel, it shows me a bunch of stuff now. So all of this stuff down here, these are all variables that are internal to the Python interpreter. Doesn't really have anything to do with the code that we've written. It just has to do with the code that the Python interpreter needs to manipulate and utilize as it's running the program that we started over here. Okay, so there are 5 buttons over here. We're only going to worry about this one right now called over. So I'm going to click over right now, and you see that it jumped to the next line in my source code. It highlighted it, and it also executed the line right above it, where it printed simple guessing game onto the screen. Okay, so the highlighted line over here is intended to show that this is the next line to be executed, but it hasn't been executed or run yet. I'm going to click over once again over here in the control panel, and you see that that line is no longer highlighted. The following line is what's highlighted. So this line was executed. It printed a blank line. You can't really see anything over here. So let's click over and have this line actually executed. So we click over, and there it executed this print statement right here. Try to guess the number between so on. Okay, so I'm going to click over again. It printed this line. So I hope you can see that we're very, in a controlled way, we're slowly stepping through the program. You click over again, it printed another blank line, can't really see anything different. We imported the random module. Okay, so look down here. So it indicates down here in the global section of the debugger that it did indeed import the random module. Now we're going to click over again, and it set my variable r_num to 0. And here is r_num, and its value is 0. Let's click over again. Okay, so it's about to, you see that it skipped past these two comments, so we're no longer printing the random number to the screen. And the next line to be executed is setting the guesses variable to 0. I press over, and there's guesses appearing in the list, and its current value is 0. Okay, let's press over again. Now guess_num is added to the list, and its current value is -1, which is what the source code over here says it's going to do. Now we enter into the while loop, and then clicking over again, we're going to see that valid input has now been added to the list of variables that we're kind of watching, and its value is false, which was set right here in this line in the source code. Now we're going to enter in the while loop. We're going to print a blank line, which you can't really see anything different. And now we're going to guess a number. And you can see the input prompt is put right here on the screen. Let's click in that window so we can enter in a value. I typically enter in 50. Let's press enter. Okay, so the input command took what I entered, and I entered a value of 50, right? And I stored it in guess_num. That's what we've been discussing the whole way through. So guess_num is now in my list of variables, and there it is shown as 50. Okay, so there's something very, very valuable to get from this. You see how 50 is surrounded by single quotes, indicating that 50 is actually a string, not a number. It looks like a number, but it's actually a string. Versus the random number, r_num, that truly is a number between 0 and 100 inclusive, and you see there are no quotes. It's an actual number. So running the debugger is, and watching what the input from the input statement is, and seeing what is set in the variable you used with the input statement gives you another clear indication that what you've just gathered in the input statement is a string and not a number. So that's very valuable to know. Okay, so now we're going to press over again. Okay, so guesses is this variable right here where we're counting the number of guesses the user makes, and that was incremented. Okay, and you can see guesses has now been added to our list of variables that we're watching, and the current variable, the current value is 1 for that variable. So now we're going to enter in our tests. And so we're going to press over again. Since lowercase q was not entered, right, we typed in the value of 50, again as a string, not as a number. That's not the same as a lowercase q string. So it skips test number 1, like we've talked about a million times already, and it's on to test number 2. and we're going to click over again. And so it's running this isNumeric method, and it failed. Oh no. So it passed, right? So valid input is now set to true. Okay, it was originally set to false up here. Now it's set to true as indicated in our list of variables. Now it's on to test number 3. We're going to press over, and it's looking at the value and is determining that yes, indeed, it is a value between 0 and 100 inclusive. So it passed test number 3. Now, the interesting thing to note here and to remind yourself, the way the while loop works is it continues looping around and around and around until such time as valid input absolutely equals false. Okay, so right now it's equal to true, right? Because it passed all 3 tests. Valid input is equal to true. Valid input is equal to true. So when it goes up to this while loop to check again, it's going to find that the valid input, valid underscore input equals true, not false, because it's not. So it's not going to re-enter the while loop again. So let's press over, and you'll see that now we're out of the while loop and we're through the data validation. And now we're on the next bit of code, which is a little bit redundant. So that's an area that could be worked on in a future version of the game, but not right now. Okay, so now we're looking again to see if the user typed in a lowercase q. They did not, so when I press over, it should skip that section, which it did, and it went down to the next if statement, and it's trying to figure out if the user entered a value that's greater than the random number. So let's look here. So we actually guessed 50 as a string, and the random number is 33. So we have to convert the string to an integer so we can compare the number 50 to the number 33. And that's what we do right here. And it should be, the program should see it as too high. So if we press over, it goes down here. Okay, so it executed that, and as soon as we hit over, it's going to print your guess is too high, guess a smaller number. And now it goes to the next if statement, which is not necessarily redundant, but it's not necessary at this time, but that's how our code is written. It's checking to see if the number we guessed matches the random number. We already know that it doesn't, right? Because we see that our guess is too high, but our code will check again right here. Again, that's an area for perhaps improvement in the future, but not right now. So if we press enter, so then it jumps back up to the while loop, okay, because it didn't find an exact match. So now we're back to hitting over again. It sets valid input back to false, which is right there. That's where it sets it in the source code, and that's where the debugger sees the value now is false. Now we're going to press over again. We're down at the input line. It puts the prompt up here again. So now let's guess, well, it wants us to guess a smaller number. So let's guess 25. Okay. I can press over again. It increments the number of guesses. So now we're at 2, right? The first one was 50. The second one was 25. It's not a lowercase q, so when we press over, it should skip over that, which it does. Now it's going to check to see if it's all numbers, which it is. Now it's going to check to make sure it's between 0 and 100, which it is. And now it jumps back up to the beginning of the validation routine while loop, and it should step out of that because valid underscore input does not equal false anymore. It equals true. So let's click over. And okay, so it's no longer in this upper while loop. It's now down here. It's out of the while loop and it's down here. It's checking to see if we typed in lowercase q, which we didn't, so it skips over that. Now it's checking to see if it's bigger or lower, higher or lower than the random number, and it finds that the guess is too low. It's 25. I guess 25. We already know that that's correct since the random number is 33. It's not displayed on the screen anymore because we commented those print statements out up here. So now we're going to press over. We go up to the while loop again. Now we're sitting at the input prompt and we have to guess a number between 25 and 50. So I'll guess, oops, so here's an interesting point, mistake I just made. I have to click in this window so I can actually enter my input. I'm going to type in 30, press enter. Continue stepping through using the over command. I know that I just typed in numbers. I know I typed in a number between 0 and 100. Now I'm checking to see it's not a Q. Now my guess is too low, just like it was the last time. Back to the while loop. There's my input prompt. So I need a number between too low. So 50 is too high and 30 is too low. So let's guess 40. So hopefully you're getting the idea how this debugger works. It's really very useful once you get the hang of using it, which I'll be honest took me a few minutes. Okay, so here's our input prompt again. 40 is too high, 30 is too low, so let's guess 35. Okay, so our guesses are still incrementing. We're up to 5 already. 1, 2, 3, 4, 5. Typed in all numbers, something between 0 and 100. It's not a Q. Okay, so my guess 35 was too high. So I need a number between 30 and 35, which makes sense because when we cheat over here and look at the debugger, we know the random number that we're ultimately trying to guess is 33. So there's my input prompt. I'll type in 33, press enter. Our guesses is now incremented to 6. Step all through this. And there you go. Congratulations, your guess is correct. You needed 6 tries. And now we're out to the Python interpreter. There's 1, 2, 3, 4, 5, 6 guesses. Okay, so I'm trying to demonstrate 2 different ways to test your Python program. All along the way up until this episode in our series, I've been using extra print statements in my source code to indicate where I am in the program and maybe the value of different variables that I'm concerned about at that point. This, using the debugger that comes with Python, is an alternative way. It eliminates the need to put extra print statements because it's watching all of the variables that are in your program anyway, plus a bunch of other stuff. So I do encourage you, once you get comfortable putting in the extra print statements, and you feel like that's a tool you can always go back to if you need or want to, then maybe try using the debugger that comes with Python. Again, you can, it's a little clunky about how you turn it on. So let me just try and show you once again. Once I'm in this idle shell window, I can turn the debugger on or turn it off. Okay, so as soon as I turn it on, which I just did right there, this debug control window pops up. If I close this window, now debug is off. Okay, let's close this window. Now, if I was to run this module, which is what we have been doing right up until this episode, and I have a prompt right here. If I go up to debug and I try to turn the debugger on, I'm going to get this error because it's already running the program. You can't turn the debugger on after it's already started executing the program that you want to debug. So there's a couple of things you could do. Let's see. I think what I normally do is if I click X here, say, do you want to kill the program? The program is still running. Do you want to kill it? I say, okay. Problem is it closes the window. So and ultimately what I want to do is turn on the debugger. So if I already have my idle shell window open and my program is running, I can actually use, under the shell menu, there's this interrupt execution, which is Control C for shortcut. If I click that, see, so it stops the program from running and it leaves me in the Python interpreter. At this point, I could click on debug, click on debugger. Now I see debug is on. Just move it over there. Now if I jump over here to my source code, choose run module, you can see I've restarted, and now my debugger is active and it's starting to record where it is in the execution of my source code. Okay, so it takes a little, I found it anyway. It took a little getting used to, but I think it's worth it. If this is too much as a new programmer and you just want to stick with the extra print statements, perfectly a-okay. I've done that for years and years and years in all kinds of different platforms and in different languages, and it's always worked. It's never failed me. However, when you get a little bit more sophisticated or want to ramp up your skills, try using the debugger that comes with Python. As a side note, when and if we get to the stage where we want to upgrade from using the IDE that comes with the Python program and maybe move up to something like Visual Code or PyCharm or any of the other Python IDEs, then we would wind up using the debugger that comes with that IDE. But for right now, I'm using the debugger that comes with Python. It's just called debugger, and I'm trying to demonstrate how to use it. So let's type in a lowercase q. Remember, we're still running the debugger, so the program hasn't actually completed yet. And now we're done. Thanks for playing. Debug is on, and I'm out of the program because it just executed the break statement, and there is no other, I can't go any further in the source code. Okay, so hopefully I've given you a very quick and albeit kind of a rough demonstration of how to use the debugger that comes with Python. It's worth taking a chance on and spending a little bit of time learning how to use it because I think it'll help you.